Hey pre-calc students, welcome to today's lesson on 5.5, finding all possible solutions for trig equations. So the main difference between this lesson and the other ones that we've done is that our domain now is going to be from negative infinity to positive infinity. So whenever you are asked to find all possible solutions, you have to assume that our domain is from negative infinity to positive infinity. So if you look down below over here, to find all possible solutions, okay, give me 1 second. Okay, to find all possible solutions under the domain of negative infinity to infinity, we're going to be adding infinitely many rotations to a function's period, okay? And sine and cosine have different periods and different requirements than does tangent. Okay, and that's based on their graphs. So the length of a period for sine is 2 pi. So let me just kind of show you. So the length of the period for sine is 2 pi because that's how often the curve repeats. Okay, so let me use different colors to show you. So the pattern for sine is this curve, okay? And if you notice, it repeats every 2 pi. Okay, so I'm going to kind of just draw it a little bit in more detail. So from here to here, the length is pi, or sorry, 2 pi. Oh, Lordy Jesus. I hope I didn't say pi before. It's 2 pi. Okay. Now cosine, similarly, okay, is also a length of 2 pi when it repeats. Let me use a different color. Okay. So the length of this one is also 2 pi. And then after the 2 pi, it repeats again. Okay, so then from here, same pattern repeats to here. Okay, so if you look to what I mentioned earlier, sine and cosine require you to add 2 pi n. So in your answers, you're going to add 2 pi n because that's the length of the period. That's how often the pattern repeats. Okay, so 2 pi n is the length of the period. Whereas tangent, that one repeats every tangent, or sorry, every pi, length of pi. So the length from here to here is pi, the length from here to here is pi. So you see that it's every pi versus 2 pi. So when I say in the directions to find all possible solutions, you're going to add either 2 pi n or pi n. You have to ask yourself, what function are we dealing with? Because if it's sine and cosine, you're going to add 2 pi n. If it's tangent, you're going to add pi n. Now, what does the n represent? That's what the infinitely many rotations. Okay, in other classes in the future, you might see people use the letter k, but n represents that you can go around and repeat this for any number of rotations. Okay, so as many times around the circle as you want to go. Okay. All right, so the first thing you're going to do is treat the problem as if the domain was just 0 to 2 pi. Okay. All right, the first example is a linear equation. I would use SADMAP for this. So I would subtract the root 3, sorry, add the root 3. Long day. That's why I'm making so many mistakes. Okay. Divide by 3. You get tangent of x equals root 3 over 3. So the next thing you want to ask yourself is what angle has opposite over adjacent that would give me root 3 over 3? Pause the video, find the reference angle that would give you tangent of root 3 over 3. Push play when you're ready. The correct reference angle here would be pi over 6. Tangent is positive in quadrants 1 and 3. So those angles are going to be pi over 6 and 7 pi over 6. Because they want infinitely many solutions, okay, pretty much any solution within a domain of negative infinity to infinity, we're going to tell them that the answers are pi over 6 plus 2 pi n, or sorry, 1 pi n, because that's the period for tangent. And we can also say that the solution is 7 pi over 6 plus 1 pi n. So remember, you're going to be adding infinitely many that's what the n stands for, infinitely many rotations. And remember, think of the period of that function. So the period for tangent is 1 pi, not 2 pi. However, one of the things that I want you guys to notice is that these two angles are 1/2 of a circle away from each other, which is a pi. So they're 1 pi away from each other. And if this makes sense, feel free to start doing this. You can condense the answers and just say, hey, if you start at pi over 6 and you add half a circle, it'll get you the 7 pi over 6. And from 7 pi over 6, add half a circle and it'll get you back to pi over 6. So you can say, instead of giving the two answers separately, you can condense them. And this is optional. I'm not requiring it from you this year, but you can condense your answers. So instead of giving two separate ones, you can just say pi over 6 plus pi n. Okay, so for the next one, you want to solve for cosine of x. You can use SADMAP because this is a quadratic binomial with no linear term. Okay, and then when you square root both sides, make sure you put plus or minus. Remember, when you square root a fraction, you have to square root the top and the bottom. So the square root of 1 is 1, and the square root of 2 is square root of 2. Okay, what reference angle do you want to use here? Well, whatever is going to give me adjacent over hypotenuse to be 1 over root 2. So pause the video here, push play when you're ready. What's my reference angle that's going to work here? Push play when you're ready. So the reference angle is pi over 4. Since our answer was plus or minus 1 over root 2 for the cosine, that means we need to give all the answers in wherever cosine is positive, which is our quadrants 1 and 4, and wherever cosine is negative. So those angles are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now, what I want you to notice is that all of these are the same distance apart, okay? They're all 2 pi over 4 apart from each other. So because they're all the same distance apart, I'm going to be able to condense my answers. But technically, if you're not worried about condensing and you want to give them all separately, you can say that the answers are pi over 4 plus 2 pi n, because that's the period. Don't forget that you have to pay attention to the trig function. Cosine and sine have a period of 2 pi. And then you're saying that there's infinitely many answers, and that's why you need the n. And you can keep going and giving the rest. Or if you understand how condensing works, you can say, hey, I don't need to write all these separately. All I need to do is tell them that if they start at pi over 4, I'm going to put or condensed. You can say, hey, start at pi over 4 and just add pi over 2n, which is the distance between all the angles, which is 2 pi over 4. Right? That reduces to 1/2 or 1/2 pi or 1 pi over 2. Remember, you can pause the video, rewind anytime you have to, okay? All right, next one. I'm going to write myself a little note that I'm going to have to multiply the domain by 3 halves. And I'm going to start by focusing on what angle has a secant of -2. Okay, so pause the video, ask yourself, do I know what my reference angle is? And where is secant, who is related to cosine? Where is secant negative? Play the video when you're ready. So the reference angle here is pi over 3, and cosine is negative in quadrants 2 and 3. So my two solutions are 2 pi over 3 and 4 pi over 3. However, since my angle was not by itself and it was being multiplied with 3 halves pi, I need to solve both of these. So 3 halves pi, or 3 halves x, I'm so sorry, 3 halves x equals 2 pi over 3 plus, plus 2 pi n, because that is the period for cosine, which is related to secant. Okay, you're going to do it again. 3 halves x equals, set it equal to the other answer. Remember, the domain is technically negative infinity to infinity. But remember I told you that we're going to have to multiply the domain by 3 pi over 2? So that is really important because when you go to solve for x and you use the reciprocal of 2/3, you're not just going to have to do it to the 2 pi over 3. You're also going to have to do it to this guy, to the plus 2 pi n, because it's a binomial. And when you are multiplying one side of an equation by something, you have to do it to every single term. So because this has two terms, it's a binomial, you have to multiply the 2/3 to both of these leading terms, okay? So you're going to have to multiply both of these. Now, there's no way to condense the answers of 2 pi over 3 and 4 pi over 3. I forgot to mention that because they're not the same distance apart. So going left to right, 2 pi over 3 is 2 pi over 3 away from 4 pi over 3. But in order for me to get back, let me just draw this out. So from here to here is a distance of 2 pi over 3, but that's not the same distance as from here back over here. So you can't condense those answers. They have to be the same distance apart. Okay, so take your time, go ahead and pause the video and multiply 2 pi over 3 times 2/3 and 2 pi times 2/3, and then see if your answer matches. Push play when you're done distributing the 2/3 to the binomial. Okay, so you should have gotten these answers. If you didn't, try again. If you can't figure out what you did wrong, feel free to reach out to me. Okay, the next example is a quadratic trinomial, so these need to be factored. Remember that I said that if you are having a hard time as is with factoring, then I would rewrite this original problem using just x's. So if you wanted to, just rewrite this without the trig function and factor it and solve it first, and then go back to the original problem. So if you factor this and set each factor equal to 0, you'll get 1/2 and 1, which is the same thing that you'll get here if you set them equal to 0, okay? So let me just show you. So if you set it equal to 0, you get 1/2 and 1. Okay, so I'm trying to figure out where is sine +1 and where is sine +1/2. Okay, go ahead and pause the video and ask yourself, what are the reference angles for both? What angle will give me a sine of 1/2 and what angle will give me a sine of 1? Press play when you're ready, but again, try this on your own first and then push play. Okay, so the correct answers are pi over 6 and 5 pi over 6. And for this one, it's pi over 2. So how do we write the answers? And notice I can't condense the answers for 5 pi over 6 because the distance from here to here is not the same as the distance from there back to the original. Okay, so your final answers are going to be pi over 6 plus what's the length of the period for sine? How often does sine repeat itself? 2 pi n. It's also 5 pi over 6 plus 2 pi n. And finally, pi over 2 plus 2 pi n. Okay, as always, if you have any questions, don't forget that you can feel free to reach out. Have a good one.